Hello everyone, welcome to this tutorial where we showcase how to implement convolutional neural network. Again, CNNs are part of deep learning, and in this project the main goal is to build, to train, and to evaluate the CNN model to classify images in that dataset, the CIFAR10 dataset. So the goal is just to categorize the images that are in there into either airplanes, automobiles, birds, cats, etc. So what we are going to do is to do data pre-processing. We're going to design the CNN architecture, we're going to train the model, evaluate its performance, and also visualize the results. And then again, as part of our process, if you have been following along, we want to also uh, load the data set with the new data and see how it's going to perform. All right, so I've already kind of taken a step ahead and imported the necessary library, TensorFlow, NumPy, and Matplotlib. So our data comes from TensorFlow carriers. That's where we're gonna get our data set. And I've already loaded the data set here. So created a function to load the data set. And now let's just continue to build the model. Alrighty. So to do that, what we need to do is to go ahead and actually let me comment here. Want to build the convolutional neural network model. So create CNN. You can remember functions. You can write them, name them the way you want. So our model. All right. Okay. Models. There you go. So what we want to do here is to create the CNN model, and there's I'm gonna use. Okay, let me just go ahead. Then I can explain after. That will help a lot. 64. So here it will be 3, 3. My activation, same. Yeah. Then what we want again, is 64. Okay. And then we need another. Activation. So what we want to do here is end up returning the model. All right. So what we end up doing here is we create the function, the CNN model function, and from this function, we want to extract special features from images using the convolution features. So we are going to use this 2D to extract those special features in each and every image. Then also I'm using max pooling 2D to kind of reduce the special dimensions, only that I want to retain only the imported features. Then I'm flattening the layers. So kind of converting them from 2D to 1D. If you don't understand the dimensions, go ahead and look at one of my either pandas or numpy video that you can walk you through. Then dense layers here, what I'm doing is I'm performing classification based on extracted features. The final classification will then use softmax to output probabilities for those 10 classes. All right. So what I want to do now is to then go ahead and compile and train the CNN model. So to do that, all right, I would need a function. Then I'll go model. Let me just do it this way so that we can have more space here. Perfect. All right, so it'll be model, test images, test labels. And so my test loss, test accuracy is equals to model all I want here is to print my test results. So what I will do is test accuracy, then my test accuracy, I want to convert it as a percentage. Then I want to go ahead and just return test accuracy. Perfect. I also want to visualize my training history. Now, from my experience, deep learning models are a little bit, in terms of resource use, they kind of take a little bit longer and than any other models. So when we visualize, it will take a little bit longer. It won't be much time because, of course, but it will be taking a little longer than compared to other, let's say, supervised learning models. So what we need to do is to want to show the training history. So my fixed size, my subplot here. Then what you want to do, right, training accuracy, and I want to do is to, okay, let me do the title quickly. So my title will just be accuracy over then Then I want to do my labels. Then Y label. Of course, we want the legend. Perfect. All right. So I'm just going to go ahead and visualize. Uh, we want to plot the training and validation accuracy over epochs and train and validation loss over epochs. When we come to check if our model is overlifting or underlifting, we need to have this result. So that's the reason why I did that. And actually, let me also keep on visualizing here and saying subplot again 1, 2, and 2. We want our loss. We also want the label. So my label is equals to, so this will be training loss now. Let me go again and plot history. History. Actually, I can just do save time in typing, copy, and paste it here. Only the difference here is I want loss. Then I want to show it all. All right. Now, if I run it, it's going to take time. So what I'll do is I will also go ahead and add new data. So let me just run it and just correct the errors. Alrighty. Just gonna look one more time and see. So I'm going to, alrighty. I'm going to, all right. So we're gonna add new data. Then we're gonna see how the model will perform based on the new data. All right. So to add a new data, you need your functions. Yeah, another function here, which I'll just call new data. So model, test images, test labels, perfecto. So I want my num images. Also, I want this goes to test images. Then I want you have my indices. Also, I would want symbol labels. And this one will also be indices. Perfect. Let me just do predictions. Now we need to just plot everything. One will be 10, 10, perfect. Let me do a for loop here. So when I use num images, for I in range num images, which is range 5, I want to plot those images. So that'll be 1 num images I plus 1. Here I want sample images. And I. This will be true. Label is equals to this will be sample labels, and I again. Then of course quickly do a title again. So for the title, I would want it to be then put a new line, and also this will be true label. Gonna get out of the loop and just show everything. All right, so what I want to do now with this is to establish the main workflow. So to establish the main workflow, what I'll do is equals to I'm gonna rush a little bit here. Labels, test images, test labels is equals to load data. Perfecto. And we want to do actual, I can comment it out, comment it here and say class names. Is it 10 dataset? Let me double check. I think it's 12. 11, 12. Can't remember. 10. Yeah. So 10. And what I want to do here is go ahead and do class names is equals to specify now those categories. So to the first one we said is airplane. Second one was automobile. Third one was bird. deer, dog, and frog. We're gonna do horse, gonna do sheep, and we're gonna do truck. Perfect. And also create and train CNN. So our CNN model is equals to create CNN. Yeah. History is equals to train model CNN model, of course, then train images and also train labels. Train labels. We want also to evaluate. So what I would do is to evaluate model. So to evaluate the model, what I would do is I'll just do evaluate model. Then I would need, oh my goodness, I'll just copy this one, control copy, control V. Then I want to visualize and train CNN. So to visualize and train CNN, you still need CNN model. Actually, no, visual. Okay. What we need is to plot training history. Then we have history here. And also we need to test new data that I created. So to test new data, I want to predict new. So I'm going to provide this full code, CNN, in my GitHub. Then you can always take it from there and see how you can improve it. I'm a little bit fast because I wanted this one to end in the next few minutes. All right. So I'm just gonna double check everything to make sure that it is as expected. And then we can run. So this one and see history. Okay, yes. All right, let me run and see. It will take some time, but I'm going to pause, and when it's done, what I'll do is I'll just share. So it's still running, and it's going to take a minute, and we'll see what the results are. So in my first complete supervised training model tutorial, I explained all these steps in detail, and on this one, I'm not going to explain a lot because when you come to deep learning, we assume that you've mastered the basics. But it's going to run all these up to 625, and it's going to also show our training history. Again, if you want to get all these datasets on your own, go to TensorFlow.keras, and actually, if you go to TensorFlow website, you can get. Let me see if I can quickly do that here. Let me open this one, and let's see if I can, while this is running. TensorFlow. Actually, let me share this screen from TensorFlow. If you really want to know, probably in the future, I'll come up with a tutorial that explains what TensorFlow is, what it does. But You can go right here if you're new to TensorFlow, and also there are tutorials here. And also, if you want to learn machine learning, so you can come right here. And the 4 areas you want to know: your coding skills, again, your basic math and statistics, probably some probability, some regression there, some matrices, the theory behind, and also building a project, which we are doing right now. So let me see if this is able to, yeah, looks like most of these courses are free. So I would say learn these concepts, and you will be able to master machine learning. So let me check if it's still running. It will take some time. All right, so how to install, where to learn, APIs that you can integrate with, then also all the other ecosystem. Let's see. Yeah, data sets. That's why I'm here. All right. TensorFlow official data sets. We've still got Google and also other resources. So you can play along and check these data sets and play around with them and see what you can get out of it. Or you can create your own data sets, depending on the project and what you want to do. You can do web scraping. You can do just create some random data, and you can create random data for your project. So I'm on 4. It's still a long way. I'm going to pause one more time, and we'll come back when it's done. All right, looks like the results are out, and let's see. Our training accuracy, the more we get data, the more accuracy increases. So we are sitting at 70%, which is good. And also, let's see if the model is able to predict. Yeah, this is a dog. It could be a deer, yes. This could be a frog, yes. This is a bird, a sheep. Yeah, I think the model is doing what it was taught to do. And the key here is to keep on feeding your model with more data so that I would want, of course, 100% accuracy is not achievable, at least as far as I know. So probably if you sit at 90% or 85 upwards, I will take it. But still, our test accuracy 70%, which is good. So I'm cool with it. What I'm going to do is I'm going to share this code in my GitHub, and you can access it from there. And I also put the link to my description. Thank you for watching. Bye for now.